Lesson 102 is called Adding Like Terms again, but this time taking a little further, part 2. So let's review what we did talk about with adding like terms. What are the situations and what can we do? What are the rules? This was a problem you had back on lesson 94 is when we talked about this last time. Which terms can we put together? Which terms will not be put together? I have an x. This is a constant, and this is a y. Yellows denote like terms. Therefore, I have 3x's, still a 4, and a y by itself. What the new lesson will do is introduce exponents and reordering variables as well, and showing like an xy instead of just an x, and what is that like terms with. So for example, by adding just this one little exponent 2, that's going to change this answer significantly. Now I'm going to tell you negative 4x squared cannot be added or subtracted. It could only be multiplied. It is not a like term anymore to 7x, and then the rest is still the same. So exponents create a new term. This is the type of problem we're going to be looking at. Let's see if we can't make some sense out of it. 2xy squared plus 3y squared x plus 7yxy. The book has kind of a two-step process to deciding what are like terms, what can be put together. First it says forget about these these coefficients, right? That's what we call them. They're not constants when they still have a variable attached by multiplication. They are called coefficients. Get rid of the coefficients, then write out the factorization for each term. There are two y's there. That's what squared means, right? And squared means two y's and an x. And over here we have a y, x, and a y. Now look for, do I have the right number of everything? There are two y's here and an x, two y's here and an x, two y's here and an x. Another thing you can do to help yourself is put everything in alphabetical order. And as you can see, it all looks the same. Therefore, yes, these are like terms. Then to finish the problem, you go back, and we had 2xy squared plus 3y squared x plus 7yxy comes out to 2 plus 3 plus 7, 12. And then you can show this part however you like. I'd prefer it that way. Oop. Slow down on me a little bit here. Well, you got the idea. So we know that the commutative property for multiplication tells us you can put factors in any order. It's the same numbers. It's going to come out the same, and that's why this works this way. Before we get to practice problems, why don't we talk about this just a little longer? If we need to simplify something like 4x plus 3 plus 6x plus 4, here it gets a little sticky, plus 2xy plus 3yx plus 2. What are my like terms? Let's start boxing, circling, triangles, whatever works well for you. I see x, that's good. Any more just x's with a coefficient? None. Constants, all positive, which is nice. And finally, xy, yx, commutative property tells me that's like terms. You combine your coefficients and have a final answer. Let's do another one. Let's try 4 plus 3x squared plus 2xx plus 4x plus 7. Yeah, let's throw in a xy. What are my like terms? Remember, the book says lose the coefficients and just write the factorization. There's no x's here. There's an x and an x and an x, 1x, nothing there, and an xy. What are the like terms? 2x is here, 2x is here, 1x here, so we could do something fancy with that, I suppose. Oops. Let's do a triangle over constants and just underline this guy over here. Now, put them together. Greens make 5xx or x squared. Pinkish colored, I still have my 4x, and it was a plus. Reds, constants, how many? 11, and of course, plus x, y cannot be combined here. Why? Because of the y. That's a final reduced answer. So you've got a couple practice problems to try this with. Remember, x squared cannot be combined with x when being added, but could be multiplied to make x to the third, right? So understand how exponents affect your adding of like terms. Good luck.